Landis interval rule. Okay. In third we have Zeeman effect, Zeeman effect, and Pasken-Bragg effect. Pasken-Bragg effect. These are very important concepts. Okay. Then we have Stark effect, hyperfine structure. Then we have X-ray spectra, X-ray spectra, and breadth of spectral line. Okay. In atomic physics, we are going to see our before talking about the hydrogen atom, we will see some prior concepts, that is the discoveries of scientists. It says what class 10 or class 9, that is J.J. Thomson's plum pudding model. Plum pudding model. It's a very famous one. Okay. Why it is called plum pudding model? Because after the realization of that atom is neutral and it consists of negatively charged electrons, so he considered that atom is a sphere of positively charged and negatively charged force atom. Important and very conceptual also, Rutherford's atomic model. Let's see Bohr's postulates. Bohr's postulates. This is very important. Okay, postulates. The first one is the electron revolves in a circular orbit around the nucleus. The electrons revolve around the nucleus in a circular orbit and the dynamics of electron is governed generally by Newtonian mechanics. Okay, so here we draw a conclusion from his first postulates, that is the centripetal force centripetal force required for circular motion is provided by Coulombic attraction of nucleus on the electron. Okay, that is Coulombic attraction, and it is given by 1 by 4 pi epsilon naught q1 q2 by r square. We have the formula of Coulombic force. Here we have electrons as Ze and uh, divided by r square is equal to, that is centripetal force formula, mv square divided by r. Okay, so the second postulate is what does the second postulate says? The angular momentum of electron is integral multiple of h cross, or we can say h by 2 pi. Angular h by 2 pi, or you can say h cross. So let us talk about the angular momentum. Okay, let me draw it for you. Okay, angular momentum of electron, let us calculate. That is the orbital. Okay, let me draw it for your better understanding. Let me draw it. Okay, this one is my nucleus having positive charge protons, and at a distance r we have electron revolving around the nucleus in its orbit, having velocity v. Okay, and having mass capital A, small a, sorry. So angular momentum formula, we have L vector is equal to r cross p. L vector magnitude will be equal to, we have p as mv, so it becomes mvr sine of angle between them, that is sine 90. Okay, so it will become mvr, isn't it? Yes, so it will become mvr is equal to n h by 2 pi as integral multiple. Okay, where n is integer having values 1, 2, 3, etc. Let us move forward with our third postulate, postulate number 3, that is electrons do not radiate energy in the circular orbit. So the orbits are called stationary orbits. Electrons do not radiate energy in the circular orbits. So the orbits called stationary orbits. Okay, is it clear to you? And one more important point is, while making transition from a stationary orbit of higher energy to that of lower energy, it does not radiate or emits energy. The electron may also go over from orbit of lower energy to that of higher energy by absorbing energy. What happens when electrons absorb energy? It goes from lower stationary orbits to higher stationary orbits, and by emitting or radiating energy, it transit sorry okay it transit from higher to lower one, higher to lower one. Okay, is it clear to you? Yes. Let us calculate radius of nth orbit. This is a very very important calculation, so be careful while you are deriving this radius of nth orbit. Okay, let us draw diagram of a circular orbit having nucleus at the center, and at a distance r we have electron having mass small a. Okay, so we know that Coulombic attraction, that is force due to Coulomb attraction, is equal to your centripetal force, that is 1 by 4 pi epsilon naught Z e into E upon r square is equal to mv square upon r, isn't it? As we are talking about the radius of nth orbit, so we are taking the subscript Rn, and here also Rn. So what do we get from it? And also we have from the postulates, that is angular momentum is equal to integral multiple of h by 2 pi, that is nh by 2 pi. Give it equation number 2 and give it equation number 1. Okay, let's see. Multiply. Now multiply equation 1 by m rn square. We get multiply equation 1 by m rn square. What we are getting? Let's multiply 1 by 4 pi epsilon naught z e square divided by rn square is equal to mv square of rn square, rn only into m rn square. Okay, what we are getting? In the left hand side we are getting mz e square upon 4 pi epsilon naught. Okay, and in the right hand side we are getting mv square m square v square, and here we are getting rn upon rn is cancelled out with rn square, so in denominator we have nothing. Okay, now see, we have rn is equal to how much? Rn is equal to how much? We have m square v square sorry, okay, mz e square upon 4 pi epsilon naught into 1 by m square v square, isn't it? Yes. What it will become? Z e square upon 4 pi epsilon naught m v square, isn't it? Yes. Moreover, we know if I will substitute here, that is, I have a formula, it is mvr is equal to nh by 2 pi. If I will have the expression for mv, okay, let me do, okay, we are good to go. We have that expression, that is mvr is equal to nh by 2 pi. mvr is equal to nh by 2 pi. If I will have to do mv, it will become nh by 2 pi, isn't it? Okay, let's do this with m square v square, so it will become square. Okay, so what it will become? Rn is equal to m square upon z into h square epsilon naught. If we solve further, we will get pi m square. Okay, let's give it a bracket. Give it a bracket. This is our final expression for radius of nth orbit, that is equation number 3. Okay, let us calculate velocity of electron in nth orbit. Velocity of electron in nth orbit. Velocity of electron in nth orbit. Okay, let us calculate this. We have, from the postulates, we have mvn rn is equal to nh upon 2 pi, isn't it? So Vn becomes nh upon 2 pi n Rn, isn't it? Further, nh upon 2 pi m into, we have Rn expression, that is nh square h square epsilon naught upon z pi m square. We have the expression from equation 3. Okay, we have put it here. Okay, so Vn will be equal to z upon n into e square divided by 2h epsilon naught. Okay, z square divided by e square divided by 2h epsilon naught. Let us give it a bracket, because this is our final expression for velocity of electron in nth orbit. Give it equation number 4. Let us proceed further by finding the expression of radius of nth orbit in hydrogen-like atoms. Let us find out the radius of nth orbit in hydrogen-like atoms. hydrogen like atoms. We have radius formula Rn is equal to Na square upon Z into H square epsilon naught divided by pi n square, isn't it? From equation 3 we have this expression. Let us give it equation number 1, and here H square epsilon naught pi n square is a constant quantity, and by putting its value, let's put its value, that is Planck's constant 6.62 into 10 to the power minus 34 square into epsilon naught having value 8.8 into 10 to the power minus 12 divided by pi 3.141 into mass of electron, that is 9.1 into 10 to the power minus 31 into electron having charge 1.6 into 10 to the power minus 19 square. By calculating, you can get the value as 0.524 Armstrong. Okay, by calculation, you can get the value, that is 0.529 Armstrong. Okay, so Rn becomes how much? Rn becomes 0.529 Armstrong into n square upon z, isn't it? Give it a bracket and give it a equation number 2. Okay, so for hydrogen atom, for example, if I will have to calculate the radius for hydrogen atom, that is z is equal to 1. Okay, Rn for hydrogen atom, I have n only 0.529 Armstrong. N square by z, z is here 1, so only n square. Okay, give it a bracket where n is the orbit number. Okay, so for first orbit, for R1 for hydrogen atom is how much? 0.529 Armstrong itself, or we can write it as 0. Means 4, which is equal to 2.12 Armstrong. Okay, other orbit also. Let us calculate for another hydrogen like atom, that is for helium plus ion, that is Z is equal to 2, because helium two, isn't it? And you can also calculate for first orbit, second orbit, and other orbits also. Let us see for another hydrogen like atom, or lithium. For lithium 2 plus, we have lithium 2 plus, we have Z is 3, atom number is having 3. Rn for lithium 2 plus 0.529 Armstrong into n square upon 3. By calculation, you can get it from here. Lithium 2 plus is equal to 0.1766 into n square. Okay, you can calculate the value of r for different orbits also. Let us proceed further. Let us calculate velocity of electron in nth orbit of hydrogen-like atom. We have calculated for radius expression. Let us calculate for velocity. Velocity of electron. Velocity of electron in nth orbit of hydrogen-like atoms. Okay, let us do it. Okay, we have velocity expression. Let us first write the velocity expression, that is z upon n into e square upon 2h epsilon naught, isn't it? Yes, give it a equation number 1. Let us see here, e square upon 2h epsilon naught is a constant, and we will have to calculate this value. That is, we have e, that is 1.6 into 10 to the power minus 19 square, divided by 2 into Planck's constant 6.62 into 10 to the power minus 34 into epsilon naught. We have 8.8 into 10 to the power minus 12. Okay, isn't it? Yes. By calculation, we can get the value 2.19 into 10 to the power 6 meter per second. Okay, you can calculate. I have already calculated this, so I am writing this value directly. You can have the calculations also. So Vn becomes z upon n into 2.19 into 10 to the power 6 meter per second, isn't it? This is our general expression for Vn. Let us calculate this, for example, for hydrogen atom. For hydrogen atom, we have Z is equal to 1. So V1 for hydrogen atom, we have 1 upon 1 into 2 into 1.9, or 2.19 into 10 to the power 6 meter per second. It will become 2.19 into 10 to the power 6 meter per second. This one is for first orbit of hydrogen atom, that is velocity of electron in its first orbit, v1. Okay, you can also calculate for lithium 2 plus, helium plus, and further you can also calculate these values. Okay, I am going further, that is for kinetic energy expression. I am going for kinetic energy of electron in nth orbit of electron in nth orbit. Let us calculate this expression. We have kinetic energy formula, that is half mv square, vn square is equal to half m. We have velocity formula as what? Z is square upon 2nh epsilon naught, isn't it? Square. So kinetic energy becomes what? Z square upon n square into your m e4 upon 8 h square epsilon naught square, isn't it? Yes. Give it a bracket, give it a bracket, give it a box. Equation number 1. Let us calculate the potential energy. Let us calculate the potential energy. Potential energy in a nth orbit. Okay, let us calculate the potential energy. We have potential energy expression. Each potential energy is remembered to give a negative sign here, or because electron and your proton electron is having negative charge, so we will have to consider the negative sign here. 1 by 4 pi epsilon naught z e square of an Rn. Okay, it will become 1 by 4 pi epsilon naught z e square. By putting the value of Rn, we have n square h square epsilon naught upon pi m z e square, isn't it? I just put the value of R, so potential energy becomes z square upon n square into m e4 upon 4 h square epsilon naught square. Okay, give it a equation and put it in a box. Equation number 2. So total energy. So total energy. So total energy becomes total energy expression, that is kinetic energy plus potential energy, isn't it? So what it will become? En will be equal to z square by n square me4 upon 8 h square epsilon naught square minus z square by n square me4 upon 4 h square epsilon naught square. Okay, so what we will get from here? Minus z square n square, okay, minus z square n square me4 8 h square epsilon naught square. This one is the final expression for your total energy in nth orbit. Okay, give it equation number 3. As we can see, the h square epsilon naught square is equal to mass of electron 9.1 into 10 to the power minus 31 into charge 1.6 into 10 to the power minus 19 power 4 upon 8 6.62 into 10 to the power minus 34 square into 8.8 into 10 to the power minus 12. Okay, square also. Get the value, will get the value, that is 21.76 into 10 to the power minus 14 joule. Let us convert it into your electron volt, that is 21.76 into 10 to the power minus 14 upon 1.6 into 10 to the power minus 19 coulomb, that is the charge of an electron volt. So it will become 13.6 electron volt. From calculation you can get this value, that is 13.6 electron volt. So our energy expression becomes En will be equal to minus 13.6 into z square, sorry, z square upon n square electron volt. Okay, minus 13.6 z square upon n square electron volt. This one is the final expression for total energy. You take equation number 4. Okay, for let us calculate for hydrogen atom. For hydrogen atom, that is z is equal to 1. So I have energy expression as minus 13.6 1 upon n square electron volt. For fast orbit, I have energy E1 is equal to minus 13.6 electron volt. isn't it? Yes. For second orbit, let us calculate for second orbit. For second orbit, we have E2 as minus 13.6 upon 4. It will become minus 3.4 electron volt. For third orbit E3 is equal to minus 13.6 upon 9 will be equal to minus 1.51 electron volt. In this way, you can calculate the energy of different orbits for hydrogen atoms. So, in calculating the energy, lastly you can get for ionized orbit we have the expression for energy. Ionized orbit we have the expression for energy. Ionized orbit means we have n is equal to infinity here. So E infinity will be equal to GeO electron. Okay, understood? Okay. So for today class we have all these. Okay. If you want, I can share the PDF with you in my channel. Okay. So thank you for watching and keep studying, keep growing. Thank you.